is the y-intercept. Write that down, y-intercept. And tell me how we find a y-intercept. Good. Set x to 0. So up top we'll have 2 times 0 squared. Again, just plugging in 0 for x. And then 0 squared minus 9. On top we'll have what? And does it matter what we have on bottom?
No, because it's 0.
Correct. So our y-intercept is at what point? 0 what? Good. And go ahead and graph that point.
Is this just practice?
Yep, pretty much. We're just going to go through like the first two together, and then I'm going to let you work some on your own. Don't try me today. Today ain't the day. Next, find an x-intercept. How do you find an x-intercept? Yes. Okay, and we talked about yesterday, you only have to set what to 0? The top, because if the bottom is equal to 0, it's what? Say it louder. If the bottom's equal to 0, it's undefined. Good. So just set the top equal to 0. And we'd have to do what here? It's just 0. You could divide by 2 and take the square root, but you know it's going to be 0. So our x-intercept as a point will be what? 0, 0. And we don't have to graph it again. It's already there. Alright, now let's look at, excuse me, if there's any holes. So the way you do that, you just factor each the top and bottom, see if anything cancels out. Well, the top we can't factor it, correct? But the bottom factors into what? Good, because you use difference of cubes. Is anything going to cancel out? No. So there's no holes. Alright, next we look at vertical and horizontal asymptotes. Does anybody remember where we get the vertical asymptote from? Yeah, setting the bottom 0, seeing where it's undefined. And since it's already factored, it's easy to see x cannot be what right here? Negative 3 and 3, right? So you have a VA at x equals 3 and at x equals negative 3. And when you think about x equals 3 as a linear equation, that's what kind of line? X equals 3. Vertical, good. So let's go ahead and draw 2 vertical lines at each place, make them dotted. So one at negative 3, these are where our vertical asymptotes are going to be, one at positive 3. We don't have to worry about holes. Do y'all remember where h of a, like how do you find your horizontal asymptotes? Yeah, you look at the powers. It's evenly matched, so a 2 on top, 2 on bottom exponents, so you do what with the coefficients? So we have a HA at y equals what? Yes, HA at y equals 2. Y equals 2 is what kind of line? Horizontal, so draw a horizontal line at y equals 2. Dotted.
Wait, why is it 2?
The powers, so if the highest exponent is on top and bottom evenly matched, you just divide their coefficients right here, which is 2 over 1. Did y'all do that in pre-cal? Okay. Alright. So y'all were wanting to like plug in values yesterday. I thought y'all were crazy. Because this is what you can do in your calculator. Everybody have a TI 83 or 84?
No.
Okay, if you don't, you can just type in the values. If you do, follow along with me on this, okay? Hit y equals and clear this out. Now, you don't have to put 2x squared in parentheses. You can type that in. But when you do divided by, it's a binomial on bottom, so you'll need to put it in parentheses. X squared minus sign. And I'm going to give y'all time to type that in first, then I'll tell you what to do from there. Everybody good? Go to second, this button right here, and then table, this button right here. And we can just look at these to graph some points, okay? We want to know what's happening at negative 1, so find negative 1 in your x value, and it's going to be at, oh, I need to fix mine. Don't do this part, okay? Oops. Let me go back. So at negative 1 is at what? So that's what you need to graph on here. At negative 1, it should be at negative 0.25. That's right about here. And then at negative 2, it's at what point? So that's right about here. And all you need is those two right there. Because you can see it's not going to hit this line because it's an asymptote, right? And you have 3 points, so just connect them right here. Now what point is at 1? What's the y value at 1? Negative 0.25, right? So it's going to be the same thing over here. And what about at 2? Negative 1.6. So that's what it's going to look like on this side. And now what's it doing at negative 4? What's the y value at negative 4? Negative 4 is at 4.57, so that's way up here. 1, 2, 3, 4.57. Do we need more than 1 point right here to see what it's going to do? It's going to approach what? Negative 3 right here, and this asymptote as well, so it's going to go down towards this one. What do you think it's going to be on the other side? Same thing. And just to make sure we've done it correctly, hit the graph button, and you can see this is what ours looks like. Maybe not as pretty, but it looks like it. Yes. Yes.
Why does it look like that?
Let me see. You might have typed it in the y equals button wrong. Yeah, you put a plus 9 on accident. Anybody else having trouble with their calculator? Cool. So y'all like this better, the table, than plugging it in, don't you? That's what I thought. Okay. Moving on to the next one. Let's start with y-intercept. You set what to 0? Well, that's just going to be what? 0, 0. Good. Sorry, it'll clear up in a minute. There it goes. Alright, x-intercept. You set what to 0, Darren?
How'd you get 0 through?
Darian, for x-intercept, you set what to 0?
X squared plus 2.
Yeah. No, not x squared plus 2. For x-intercept, you set y to 0, right? Did you answer my question? You know this. Y-intercept, you set x to 0. X-intercept, you set y to 0, right? You know that. Because if you set x to 0, this will be 0 over 0 plus 2. Which will just be 0. And now if I set y to 0, I just have to set the top to 0, right? So if I set x fourth equal to 0, it'll be what? Good. Go ahead and draw that dot. Alright, for my VA, or first let's check for holes, sorry. Can we factor the top? Can we factor the bottom? Yes or no?
No.
Nope. So we don't have any holes, no holes. Alright, for my VA, I set what to 0? Yes. Set that bottom equal to 0. Tell me how to solve. Subtract 2 and square root, and we're going to get what kind of number? So, do we have any VAs? No, because imaginary numbers are not on the coordinate plane. So no VAs. What about HAs? Why? It's top heavy. Good. The highest exponent's in the top, so there's also no horizontal asymptotes. So we're really going to have to use our table on this one to find values, okay? So go ahead and plug this one in to y equals. Make sure you put the bottom in parentheses. And then go to second table. Jalen, go and put this one in. Try it. And then make sure your table values kind of look like mine to make sure you typed it in correctly. Alright, Brandon, at 1, what's my y value?
0.33.
That's going to be like right about here. Abigail, at 2, what's my y value? Did you type it in your calculator? Oh, you don't have one. I'm sorry. Alyssa, what's my y value at 2? What'd you get? Good. So 2.67 is going to be somewhere up here. And let's just skip to -1 and -2 to get an image of that. So what does your calculator say for -1? Anybody? Good. Oops, let me go back up. 0.3 repeating. And then what about for -2? Yes. So now connect them, and this is a what? Parabola. Very good. And make sure your graph's good. So go to graph, check it out, and you can see that's how theirs looks too. Alright, do y'all feel comfortable with finding all 4 of these? The asymptotes, there's no vertical asymptotes because when you set the bottom equal to 0, it's going to be imaginary when you solve. There's no HAs because it's top heavy. Yes. Alright, we're going to just do the identifying part first, and then I want you to graph it on your own, okay? So let's try the skin there. For y-intercept, you set what to 0? Good. Okay. So if I set x to 0 here, all the x's go away, right? I'm left with what on top and on bottom? So my y-intercept is 0, -1/3. Good, because that 6 is negative. Everybody see that? All the x's disappear, so I'm just left with 2 over -6. That simplifies to -1/3. Miles, what do I have to do to get the x-intercept? I set what to 0? Very good. Alright, so that means I just set the what equal to 0? The top. So I'll have x plus 2 equals 0, so my x-intercept is -2, 0. Go ahead and graph those 2 points. So 0, -1/3 will be like right here. Oh gosh, I said I wasn't going to do that. You graph them on your own. Let's check for holes. The top, can we factor it? No, but can the bottom we factor it? Into what? X plus, and so will these two cancel out? No, because one's plus, one's minus, right? So will we have any holes? No holes. Alright, vertical asymptote, we set what to 0? The bottom, so I'll have a VA at x equals what? And x equals 2. Alright, are these evenly powered? The bottom is the one with the highest exponent. Bottom heavy means you'll have a HA at what? Y equals 0. Go ahead and try to graph this one on your own. Graph all this first. These points, then your VA and HA, then use your table to help you with points. Let me know if you need help. Your next test on this will be coming up next Friday. I keep thinking you're raising your hand. I'm sure you are. That's where your vertical axis is, so it won't touch that point. Did you type it in? Okay. Yes. This part. X plus 2. Divided by. And then put that in parentheses.
I got it.
Let's go over how to graph this thing together. There can be a horizontal asymptote at 0 and it's still across it. It's these two pieces. It's supposed to be these two pieces that have a horizontal asymptote at 0, but it doesn't look like it. Yeah, it's supposed to look like that, but I don't know why it doesn't match up with our horizontal asymptote. Alright, did y'all draw your asymptotes already on the graph?
Yeah.
Nope. Go ahead and do that if you haven't. And then one at y equals 0 is going to be that x-axis. And then I didn't graph my x-intercept. Let me do that. Alright, tell me what the y value is at 1, somebody.
At 1?
Yes, look at your table. 0.5, everybody agree? Alright, what about at negative 1? Negative 1.333. So this one's going to look like this, going up towards this asymptote and up towards this one. It doesn't look like that.
No.
Why isn't the graph on the calculator like that?
Mine be more like they are cubes something. Wait, so we can cross a
Horizontal asymptote.
not a vertical. This ordinance?
No, with the horizontal asymptote, what usually happens, Cade, is the middle part, if it has 3 parts, and this one does, the middle part will be able to cross 0, and the outside will have the horizontal asymptotes at 0, but this one's different.
Bananas.
Yeah, I know.
And who chose the mark through that?
No. And then look at this. I just typed in x plus 2 divided by x squared plus x minus 6, and my graph looks like this. That's not right.
That's what I'm
Wait a minute. Wait, how does it
That's what yours looks like?
Yeah.
Okay, mine look like this.
Yeah, I know.
Mine looks like a 6 on the first one.
Let me try it one more time. Oh, you have to put parentheses around both of them. Remember, it's a binomial and a trinomial.
Yeah.
Because if you do x plus 2 without parentheses, it thinks that you're doing x plus 2 divided by this. Does that make sense?
That's what
Plug it in again. Use parentheses around x plus 2. Anytime it has more than one term, you need to use parentheses. And then, Kay, did you do it by plugging in numbers?
I did.
And what's your graph look like? I'll have to research why this one's... Yeah, this is what your graph should look like. Kay, yours didn't look like this?
Well, I got two outside, got the inside. What is negative 1?
Negative 1.67.
Negative 1.
I'm going to graph mine correctly in green, okay? Now that we have the correct table, the value at 1 is negative 0.75. Go ahead and regraph that one. That's going to be right about here. Negative 0.75. At 0.5, negative 1 is negative 0.1667. Yeah. So it should be really close to 0. And then this one's already correct. because that was our x-intercept. At 0, it should be at negative 0.33.
That's funky.
Yep. So it's going to look like this.
Outsmart calculator.
Alright. Yeah, it's all about how you plug stuff in. And then for number 3, when we plug that in, it should be 0.833, so almost a 1. We really don't need another one on that one because we know it's going to go up towards this asymptote, down towards this one. And then at negative 4, oh, I'm going the wrong direction. It's going to be at negative 0.33, which is right here. There we go. So you can see, like I was talking about, the middle piece can go through 0. The outside pieces are what has the horizontal asymptote at 0. Alright. I'll give y'all time to finish graphing, then we'll move on to the next one.
Ms. Horton?
Yes.
I think like in the left part, it's supposed to be going that way.
Which way? This way?
Yeah. I don't know how to say it.
Like this.
Yeah, it's like that.
Yep.
Okay.
I got you. Because as we're going towards each asymptote, this one was not. Sorry, that one was weird.
Can that?
Yes.
So problems that have 3 pieces like this, the ones on the inside, they pay attention to the vertical ones, while the ones on the outside pay attention to the horizontal.
Yeah. On the outside, it's really vertical and horizontal, but on the middle one, just the vertical. And not all of them will have 3 pieces, as you can see that we did right here. Just this one didn't have 3 pieces. This one did. All right. Next one. We'll do just the parts together, and then I'll let you graph it on your own. Hopefully this one won't be terrible. Alright, y-intercept is when we set what to 0? X. So what's going to be our y-intercept here? 0, because you have a 0 on top. X-intercept, we set what to 0? So basically the top, and you'll get what? 0. Go ahead and graph 0, 0. Alright, let's do holes first. Can we factor the bottom?
No.
Can we factor the top?
No.
Okay, so no holes. What about vertical asymptote? We set what to 0?
2x.
The bottom. Good. What do we do then, Solomon?
2x squared is 2x squared equals positive 4.
Very good. And then we divide by?
2.
And then we get x squared equals 2. And then we do what?
X equals plus or minus square root of 2.
Yes. And let's go ahead and find out what that is so we can draw our VAs. What is square root of 2? Just type it in. 1.41. So negative 1.41 and positive 1.41 are our VAs. What about horizontal asymptote? What do y'all think? At y equals 1/2. Good. Because it is a 1 on top there, and can't forget about this coefficient right here. Alright, draw your VAs and HAs, and I'm going to do the same. Negative 1.41. I'm going to just draw mine at around 1.5. Then 1.41 on this side. And then our HAs at 1/2. And then go ahead and try to graph the other points on your own, using your table.
Question.
Yes.
Where and how do you find that
HA, it depends on the powers. So see how these two have a power of 2? They're evenly squared, right? So the horizontal asymptotes are their coefficients divided by each other, 1/2.
Oh.
This one's not evenly matched, right? The high six points in the left. So it's 0. Bottom heavy is always 0. Right here, they're evenly matched, so you divide and you'll have an HA at 2. Good. That was, yeah, just think about that one. And this one has powers of what? horizontal is 25. 1 point bigger than 5 is. What was that question again? Okay. I think you described it. In between that. Yeah, so now go to the second table. And now we're at -2, the value of 1, so that's the graph exam. Go ahead, grab some.
Alright, can I borrow your checkbook? This is how your graph should look. And she only had to graph like this one to know it's not going to touch this asymptote or this one. So it's going to look like this. Same thing here. And this one, she knew that it couldn't cross this line, so you go down on both sides. So you only had to graph 3 on this one. Any questions? We're good? Alright, last thing we are going to learn about today, thank you, are slant asymptotes. Slant asymptotes. And what they are, you know, asymptotes so far have been vertical or horizontal. Slant just means that it's going across a linear line. Write that down. Slant means across linear line. Okay. First, what I want you to do is go ahead and type this in your calculator and look at the graph. Look at the graph first so you can see what a slant asymptote looks like. And I'm going to type it in too. Make sure you put the top and bottom both in parentheses. Don't forget. Again, make sure both are in parentheses.
Yep.
And yours should look like this. So you see how it's kind of sideways, kind of funky looking? It's because the asymptote is across a linear line. Now for this one, and I'm going to show you how to find it, it's across y equals x, the identity function. Y equals x. See how it's approaching that line if I were to draw a line here but not touching it? And this is how we find out our slant asymptotes. We got to use good old synthetic, which I know y'all like. Alright, what do we put on the outside if we were doing synthetic? 1. Very good. What goes on the inside? 1, -1 and 1. Good. Oops, sorry. Let me try to clear it up. Okay. Justin, what goes right here?
1.
Colby? Brandon?
0, sorry.
Abigail? Alyssa? 1? Good. Okay, for slant asymptotes, we're not worried about the remainder, so you could just cross that off or not even do it. We're only worried about this part, okay? Now, here's what we're dividing by. So if I were to write my answer, it would be what? Just x. So again, your slant asymptote is y equals x. And you can see on the graph that's what it's going across. And to make sure, I want you to do this. Everybody hit y equals on their calculator. Go down to y2 and put in what? X. Hit enter, or excuse me, graph. See how this is approaching this line we just drew? That's how you can check if it's a slant asymptote. It should go in the middle of them. Does that make sense? Okay. Alright. Let's do one more together. That's it. Just finding out the slant asymptote. Slant asymptote. The asymptote? This one wouldn't have an HA because it's top heavy. It has a slant asymptote, not a horizontal asymptote.
How do you find that again? Sorry.
You just do synthetic and then write your answer. This is X. Y equals X.
Alright. I don't really understand
Understand what part?
that. Can you like show me the graph again?
Yeah, sorry. This was it. Let me undo the slant
Why does it
asymptote.
stop in the middle of it?
Oh, good.
Yeah, why does it do that?
Why does it
in the middle?
stop in the middle?
Yeah, isn't that the asymptote right there in the middle?
Yeah, this is the asymptote right here. This Y equals X line. You're asking why does it skip values right here?
Oh, because it goes across the orange.
Yeah,
It goes.
because this is the line that, let me show you again. This is the asymptote, so this part it skips because it can't hit this line right here.
Why not?
Because it's the asymptote. Vertical, or excuse me.
Oh.
Slanted asymptote.
Okay, I'm sorry. I see now. My bad.
Okay. Alright, let's try the next one together. And the reason you tell they have a slant asymptote is because see how all of these are top heavy? All of these have the higher power in the top. That's how you know it has a slant asymptote, if the higher power is in the top. So we'll divide using synthetic first. What goes on the outside?
Is it 0?
Not sure? Then we can use what type? Not synthetic, but long division. It's so tiny. It's a short division because it's so short. Alright, what do I have to multiply this by? X. Good. What goes underneath? And then nothing here, right? So bring down. What do I have to multiply X by to get -1? Or actually, that's the remainder. I'm sorry.
Yeah.
That's the remainder. So remainder doesn't matter. What's our answer? Y equals X. Same thing. No, these will not always be the same. I want you to type in both of these equations. I want you to type in x squared minus 1 over x. X squared minus 1 over x. And I also want you to type in the second one, your slant asymptote. There you go. Oops, sorry. And you can see that's where our asymptote is supposed to be, because it approaches it, but never touches it. Any questions? Do the last one on your own. Find out where the slant asymptote is, then check with your graphing calculator. Yeah, you didn't raise it to the power right here. X. Yeah, so X first. Raise this second. And hold on a second before you start. You gotta put this in parentheses. Sorry.
What are you doing?
Minus 1 close parentheses. Divided by X. Good, and then go down 1. And you're going to type in just X here. Hit graph. Good. So that is your rational function. This is your slant asymptote that is approaching this line. You're good. Try this one. Plus. Good. Did you type both of them in?
Something's wrong with mine.
This one you need to type in the correct answer. It should be X plus 4. Good job. That's right. Correct. Yeah.
How many lines should there be?
I'm not sure why I can't do it. Minus 4.
Did you type in the original function?
Wait, is it -4?
You can type in
Okay. No, because it's like yeah, but then there's only like one line on there. You get that? So I'm real confused. You get that? Yeah. That's it, baby.
So you're gonna find out the relationship.
May I have your attention, please? May I have your attention, please? Just a couple of important announcements about tonight. First and foremost, I just wanted to say we wish our varsity football team very well tonight in the game at Hooper. And I hope that all of our students and everyone here shows up tonight and be loud and proud for our Warriors in the region championship game tonight. Students, just wanted to let you know that we are going to section off a place for you next to the band tonight. However, that section will not be reserved up until about 6 p.m. tonight. So you can't expect to walk in right before kickoff tonight and go to a student section and sit. Tonight is going to be very different. So students, if you want to sit together tonight and have a section, you need to get there early and get to your reserved place, because at 6 o'clock tonight, that reserved seating will not exist. So you need to get there early tonight, and that goes for everyone who plans to go tonight. Traffic is going to be heavy, and the place, the parking, and the stadium will fill up very quickly tonight. The gates open at 5. So I just wanted to remind everyone about that, but especially students tonight. If you want to sit in the student section, you need to get there into the stadium and into that section before 6 p.m. tonight, because that is the amount of time that we will have to reserve that. And that's all for now, guys. Let's have a great rest of the day. Let's be Warriors strong.
All right, here's the answer for the last one we were doing. Any questions?
People get to the game at like 4 o'clock.
All right, y'all can pass up if you're good with it. If not, let me know if you have questions.
I'm not good with Actually, I'm close. I ain't got nothing thermal for y'all gonna be in the hoodie booth? The food? Or the honey tree? The tree? This is getting worse and worse. It's a honey something. Into the post. The post, yeah. Gotta be in the post. How about the fierce? There's stands. Tree stands.
Are you going crouch?
Keep phone. You said they had
If you already don't need to have video on that order, they send you in the shower. You can like show you stuff. You know what I'm talking about? Send a picture and stop. You don't know. You like take smashes it in your face and all bunch
They're doing that, like, wild stuff. No, this is crack right here. Let's take a real Or they bite it. Yeah. That's nice. That's good. One shotgun. Shot me, bro.
Good luck to y'all this weekend and to y'all tonight. Y'all gotta win. No pressure. Don't get too far.
I should get on that.
Oh, that's so cute.
Take your socks.
It's apple juice.
Got your prosthetic?
Indeed.
That was, you know, the stuff that you worked on. Wait, what was it?
Yeah, I'm missing. I saw a 0 for that too. Because I remember giving it to you with the too.
And I'll write you all that. stuff we worked on. It was like notes we took one day, and there were handwritten. And it's like, oh, in class. You know what I'm talking about? It's like these problems.
Yeah, I know.
These. That we did in class.
Yeah, okay.
Just practice each other.
Okay. I didn't know we were supposed to turn it out.
Yes. Yeah. But I'm sure you reviewed that day. Yeah.
Cause like this doesn't jog my memory or anything. She got it
They're on
down.
Google Classroom.
It is?
Yeah,
Oh, they're
that's
on
it.
Google Classroom.
And we did them today, like we did them one day in class together. I know you were here.
I must have been out of it that day.
Yeah.
Okay. Well, I will have this to you.
Okay.
Thank you.
Thank you.
I don't think I put my name on it.
Okay.
Thank you.
No, I did the sickest thing yesterday.